Ever wondered why it's so challenging to separate different types of solids? Well, it's a lot like trying to find a needle in a haystack. However, with the right techniques and tools, it's entirely possible. Today, we explore the various methods employed to separate solids, making the seemingly impossible task possible. First off, let's delve into the method of separation by appearance. It might sound simple, but this method can be highly effective, especially when dealing with solids of distinctly different appearances. Here, a pair of tweezers becomes an indispensable tool. With careful observation and a steady hand, one can pick out one type of solid from another, based on their visual characteristics. Next, we have the separation by size. Imagine a sandbox filled with both large pebbles and fine grains of sand. To separate these, a sieve with holes of the right size can be used. The smaller sand particles will pass through the sieve, while the larger pebbles will be retained. This method is not only efficient, but also easy to execute. Then there's the technique of winnowing. This is a traditional method used primarily in agriculture to separate grain from chaff. A breeze or an artificial source of wind is used to throw the mixture into the air. The lighter particles are carried further by the wind, while the heavier particles fall closer. This way, the solids of different weights are separated. Moving on, we encounter the method of separation by magnetism. This method proves highly effective when one of the solids is magnetic. A magnet can attract the magnetic solid, effectively separating it from the non-magnetic solid. This technique is particularly useful in recycling centers to separate ferrous materials from mixed waste. Sublimation is another fascinating method for separating solids. Certain solids, such as iodine and dry ice, transition directly from a solid state to a gaseous state, bypassing the liquid phase. By applying heat to a mixture containing a sublimable solid, the solid sublimates and is collected separately upon cooling and condensation. The method of separation by solubility exploits the different solubilities of solids in a particular solvent. The solid with higher solubility dissolves in the solvent, while the less soluble solid remains. The dissolved solid can then be recovered through evaporation or crystallization. Lastly, we discuss electrorefining. This method is commonly used in metallurgy to refine metals. By applying an electric current, the impure metal dissolves and is deposited onto a cathode, leaving behind the impurities. In a nutshell, separating solids may be a complex task, but with the right tools and techniques, it's perfectly achievable. Today we've explored 7 methods: separation by appearance, size, winnowing, magnetism, sublimation, solubility, and electrorefining. Each method has its unique applications and effectiveness, making the world of solid separation a truly fascinating one to delve into.